So here is your test review for chapter 4. So you're just taking the indefinite integral. There's no a and b, right? So I can just use, these are all separate terms. They're all in the numerator, so I can just use the power rule, right? So I'm just adding 1 to the exponent and dividing by that new exponent. This be x to the first. So divide by that new exponent, and then add the x on that one, and then add a c at the end, right? So just reduce this 2/3. You can leave it, oops, you can leave that as a fraction there. 3 halves, 2 minus 5x, and then plus c. Okay, so as we move through this next one, now this next one, there's actually multiplication here, right? And we have nothing in, we have fractions, so we need everything in the numerator, right? So we could rewrite this. If you want to switch the dt to dx and switch all those to x's, fine. So if we have a t on bottom, that'd be a -1 exponent. And then this would be t to the -2 minus 3t to the -3. Right, and then I can distribute that. I can distribute that t to the -1. So I'd have the integral of 2t to the -3 minus 3t to the -4. Correct? So, and then we can apply the integral of the power rule. Okay, so make sure you simplify it first till you get all separate terms, right, and nothing in the denominator, and then take the integral. -3 plus 1, so that'd be divided by -2. -4 plus 1, so that'd be divided by -3. And simplifying that, you just get -t to the -2 plus t to the -3, and then we just add c because we have no a and b, correct? And then you could rewrite this if you wanted to as a -1 over t squared plus 1 over t cubed plus c. Okay, this next one, same kind of thing. I need to rewrite it as one fraction, right? So I can rewrite that root as a half power. And then again, I can separate this. Since it's divided by one thing, 3 things divided by one thing, I can separate it into just putting that either 2 ways. I can bring that to the top and distribute it, kind of like I did the last one, or I could individually put it under each one like that and separate it. But in the end, it's gonna look the same. Okay, so I can do that, and then I can move those to the top by taking the negative exponent. It would be the same thing as rewriting this like this and distributing it. Right, so kind of like the same as the last problem. Either way, right, we're going to get an x cubed minus a half, right? And that's not taking the integral yet. Okay, that's just bringing this 1/2 to the top or distributing this -1/2, right? So if we do that, we get 2.5, which is what, 5 halves? And then x2 minus a half, so that'd be 1/2, which is 3 halves. And then all I'm doing is distributing this, and then plus 2 to the x, 2x to the -1/2. So now they're all individual terms, and now I have it all in the numerator, so then I can apply and take the integral. Okay, so 5 halves plus 1, which is 2/2, right? So that'd be 7 halves. So I'm dividing by 7 halves. And then 3 halves plus 1, which is 2/2. So that's 5 halves. So I'm dividing by 5 halves plus x plus 1, which is 2 halves. So that becomes 1/2. So I'm dividing by 1/2. Okay, and so that is going to equal 2/7 x to the 7/2 plus 2/5 x to the 5/2 plus 2, but I already have a 2 out there, right? So that's going to be 4. 4x to the 1/2. And then we just have to add c at the end because we have no a and b. Okay, so number 4 here. Here is a little bit different, right? We have a function times another function, right? So we could do two things with this. We could either, no, there's only one thing. We could rewrite this as a half power, right? And again, we have no a and b, so it's just the indefinite integral, so we just have to add c at the end. So I want to rewrite this as half power. Okay, dx. Okay, so this, we can't FOIL that out, right? So if that was a 2, you could FOIL this out and then distribute that and then do it, or you can do substitution rule. This, because we have a half power here, we have to do substitution rule. Like I kind of said before, anything inside the root, that's usually our u, right? So if I let that equal u, so u is equal to 2x squared plus 2x plus 5. So then my thing would be u to the 1/2 times by 2x plus 1 dx. So this is what I need my du to equal, right? I need my du to equal 2x plus 1 dx. Well, if I take the integral of this, right, take the integral of this, I should get u, right? And I take the integral of this, right? That is going to be x squared plus x plus c. And so it's almost equal to this u, right? So what do I have to times this by in order to get it to be this u over here, right? So if I times this by 2, right, you don't have to worry about the c because it's just a constant. We can actually add it after we figure out what it needs to be u. So we distribute that 2. It looks like that, except we have the 5 at the end, and that's where our plus c comes in, right? So that constant is always taken care of. Okay, so what did I have to do? I had to multiply by 2, so that means I need to multiply this by 2. Well, if I multiply that by 2, that means on the other side I have to divide that by 2, right? So this is going to be 1/2, right? It's going to be 1/2, and then it would be that. Okay, so my du, in order for it to equal 2x plus 1 dx, it needs to be a half du. So then we can substitute that in, u to the 1/2 times 1/2 du. Now I can move the 1/2 out front of the integral sign, and now I can take the integral. Now I can add 1, which is 2 over 2, and divide by that same number 3/2. I already have a 1/2 out front, so it becomes 2 over 3 times 1/2 u to the 3/2. Oops, 3/2. 2's would cancel, so I'd get 1/3. Now I can plug my u back in, which was 2x squared plus 2x plus 5. And that's raised to the 3/2. And then again, since I don't have an a and b here, I can go ahead and just add c at the end. Okay. Okay, number 4 here, again, I'm taking a function x cubed and I'm timesing that by the function of cosine of something. So again, usually if it's taking the trig function of something other than just the variable, then we usually let u equal what we're taking the trig function of. Okay, so substitute that in. We got cosine of u, which I know the integral to, times by x cubed bx. So that means I need du to equal x cubed dx, right? So I am going to take the integral of this. This would I would get u, right? Take the integral of this. I would get 1 over 4x to the 4th, right? And then, of course, add my constant. And that takes care of that plus 2. That's the constant, right? So how do I get it to just to be x to the fourth? Well, I need to times this by 4. So that means I need to times this by 4. So if I try to get x cubed dx by itself, I would have to divide that by 4. So this is going to turn into 1/4 du. So then I would get x cubed dx, or x cubed dx is 1/4 du. So then we can substitute that in. Cosine of u, 1/4 du. I can bring the 1/4 out front. Now I can take the integral, which is sine. Okay, and then I can substitute what u is, which is x to the fourth plus 2, and then just add c. There we go. Okay, on this one we do have an a and b. So here I have an a and b, 0 and pi 4, so I want to take the integral of it and then apply the f of b minus f of a and evaluate it, right? So here they're in the numerator. I know the integrals of each of these, right? They're separated by a plus, so that means I don't have to do substitution rule. So I can just take the integral of secant squared x, which I know would be tan x, and then plus the integral of cosine of x, which I know to be integral to be sine of x, right? So then I can just apply and put 0 to pi fourths. So then I can plug in pi fourths, so tan of pi fourths, which is 1, plus sine of pi fourths, which I know is root 2 over 2. Subtract, plug in, make sure you have parentheses here since we have two terms here. We got to distribute that negative. Tan of 0, or the tan of 0, which is 0. And then minus sine of 0, which again is 0. So distribute that negative. If we had numbers there, I'd distribute the negative, but we don't. So this just becomes 1 plus root 2 over 2. Okay. All right, this next one here. Okay, again, we have an a and a b, so we're just going to take, again, these are in the numerator, and no negative exponents, so no function times a function. There's plus or minus, so we can just go ahead and take the integral. 3 1 plus 1 is 2 minus 5, and add x. Okay, so we get 2/3 x cubed plus 3 halves x squared minus 5x. These ones kind of stink because there's fractions, right? But we're going to go from our a to b, so 0 to 1. So we're going to plug in 1. And whenever you plug in 1, all you really have to do is just look at the coefficients, which is kind of nice. So really it's just 2/3 plus 3 halves minus 5. And then I got to subtract again. Might have to be careful here. This one we don't have to really be careful because we're plugging in 0 and everything's just going to be 0. But normally I distribute that negative. Okay. 0 squared minus 5 times 0. So plugging in 1 and 0 is really nice because that's not going to change things. So I just need what times this by 2. So that'd be 4/6 times this by 3. So that'd be 9/6 times that by 6, which you get 36. So that's negative 21, negative 17, negative 17/6. Okay, so that's how you finish up those problems. Okay, this problem looks a little bit different. Okay, so looking at these problems, let me fix this a little bit for you. Oh, just a second. Okay, there. So it looks a little bit different. Find the area bounded by the curve, by the given curve and the x-axis. So basically, it's just really wants you to find the integral, right, from 1 to 2. So there's we're taking the integral of this function, 3x cubed plus x squared all over x. And from 1 to 2, that's just your a and your b, okay? So really, that's all you're doing. Okay, and we can rewrite this, put the x under this one, right? Put the x under that, that would be an x squared. Put the x under that, which is just x. Okay, just simplifying there, you can bring it to the top with a x to the -1 and distribute it. You're going to get the same thing here. Okay, so we're taking the definite integral this time, so we can apply the power rule. So 3 plus 3 over 3, those cancel the 1, and we get just x squared over 2. So we get x cubed plus 1/2 x squared, and we're going from 1 to 2, so we plug in 2, so that's 8. Plug in 2, so that's 4. 4 divided by 2 would be 2, so we get 8 plus 2. Then we got to subtract, plugging in 1, so here we got to make sure we distribute that negative 1/2. Okay, so we get -1 minus 1/2, right? Distribute that negative. So we get, simplify that, and we get 17 halves. Okay, so we just put it in terms of halves, so that'd be 16 halves, that'd be 4 halves, that'd be 2 halves, and then we can simplify that. Okay, so this next one, same kind of thing, asking for the same thing. This is your function, and here's our a and our b. Okay, so we can go ahead and use the power rule, so that would turn to 5. I'd be divided by 5. This would turn to 3. Oh, that's not subtraction. Divided by 3. All right, so I get x to the 5th minus 1/3 x cubed from -1 to 1. So here I plug in 1, and then I'm going to subtract. Make sure you distribute that negative. Plug in -1. Okay, so I get 1 minus 1/3 minus -1 plus 1/3. Then I can distribute that negative. 1 minus 1/3. Bring this down a little bit. 1 minus 1/3 plus 1 minus 1/3. So we have -2/3, and we have 2, which gets me to 4/3. Okay. All right, last one here. Working with finding the area under the curve of this function with getting rid of 1 to 3, use the limit of a sum. Feel free to use familiar summation formulas. Feel free means go ahead and do it. Okay, so this is where we're going to use the limit as n goes to infinity. So what was this? 4.2 section. And then the sum I equals 1 to n of this function f of xi times dx, right? Or I guess it would be change in x, right? So we're just going to use this formula. So remember, change in x is equal to b minus a, which they give you on the interval. So 3 to 1 over n, and we just leave that as n, right? So that'd be 2 over n. And then xi is the change in is a plus the change in x times I. So that would be a is 1 plus our change in x is 2 over n times I. Okay, and now I want to plug that in to find f of xi. So I want to plug my xi into my function. So 3 times 1 plus 2 over ni squared plus 3 times 1 plus 2 over ni. I guess the i's on the side. And then minus 5. Okay, so that's my f of x part. So that's just this part right here. Now I got to times it by the change in x, which is 2 over n. And then I'll be taking the sum of that, and then I'll be taking the limit, right? So I just simplify it first, right? So I got to FOIL this out, okay? So that is 1 plus 4 over ni plus 4 over n squared, I squared, and then distribute that 3. I get 3 plus 6 over ni minus 5. Okay, and still taking the sum eventually, and still taking the limit eventually. Okay, so I can distribute that 3. N squared I squared plus 3. So I could really probably combine that 3 and this 3 and get 6, right? And then minus 5, so I get 1. But I'm kind of thinking ahead, simplifying sum of that, limit of that. Make sure you times by the change in x at the end. All right, so then we can simplify this. All right, we get 3 plus 3 minus 5 is 1. We have an I here, and we have an I here, so that's a total of 18 over ni. All right, then we have our squared. So 12 over n squared times I squared. Okay, and again, we're still timesing by our change in x. 2 over n, still eventually going to be taking the sum, and then we'll be taking the limit. Okay, so now I distribute that 2 over n, so I get 2 over n plus 36 over n times I plus 24 over n squared, I squared times I squared. Okay, and then now we'll be taking the sum of these and then taking the limit. So taking the sum would be the sum of 2 over n, and then plus the sum of 36 over n times I, and then plus the sum of 24 over n squared I squared. Now the over n's part are really just going to be numbers, and then I'll take the limit. So really these are just constants, right? And so the sum of a constant is just taking n times that constant. So n times that constant. So those are going to cancel. I'll just get 2, right? Still eventually going to be taking the limit. Okay, so then I can bring this 36 over n in front of this sum. Same for this 24 over n squared in front of the sum of I squared. Plus there. Okay, and then I use my limit laws. Let's say the limit of a variable I from 1 to n is n times n plus 1 over 2. And then I'll be timesing that by 36 over n. So what's nice, because the n's would cancel out there, right? No, sorry. I forgot to distribute the n back here. Oopsies. Right here, this n. So this would be actually n cubed. This would be n squared. And this would be, I did that one, 2 over n. Yeah. So this is a squared, and this is a cubed. Now you're probably confused when I was doing that. So this is going to take out one of those n's. So I'm still going to have, and then 36 over 2 is 18. So I'm going to have 18 over n times n plus 1. Yeah, this is a cubed. This one's a squared. Okay, sorry about that. And then I squared is the formula. N times n plus 1 times 2n plus 1 all over 6. So 6 and 24 will reduce. So I get 4. And then this n is going to cancel with one of those n's. So I get n squared on bottom times n plus 1 over 2n plus 1. Okay, and then out here I just have 2. And eventually I'll still be taking the limit. So why I want to make sure, and I knew I messed up, is because eventually when I put this n over the n plus 1, it's going to become the n over n plus 1 over n, right? I can separate it like that, because just like I did on those integrals before, if I have a variable on bottom, I can bring it to the top, taking a -1 and distributing it, right? Or just putting it under each term on top. So same thing here, I can take this n and just put it right here underneath that one, and now that one I still get an n squared, correct? So I still get an n squared. And then I can do the same thing as I just did here. Right, I can put this under this, same thing, right? And then it goes under that just like that one, so this becomes n over n plus 1 over n times 2n over n plus 1 over n. And why I need more n's eventually on bottom is for when I take the limit of these as n goes to infinity, these ones are going to go to 0. N over n is just 1, right? But when I take the limit of this one, that's going to go to 0. Okay, so then I'll just get 2 plus 1 plus 0. And then this one, I get times, and this will be that. This will be 2. So then as I take the limit of this, right, I'll be taking the limit of this one, which is just going to be 1 plus 0. Because I'm taking it as n goes to infinity. So 1 over 20, 1 over 30, 1 over 40 is just getting closer and closer to 0. And this one will also just get closer and closer to 0. So that'd be 1 times 2 times 4. So then I just get 3 plus 8. Okay. Oh, I didn't read. I got my 4 there. That's good. Okay. This one right here, I forgot my 18 out front. So that's 18 in front of this. Now you're probably really mad at me. Okay, I got that 18 out front. So that would just turn to 18 here. So that would turn to 18. 18 plus 0 is just going to be 18. So then I get 18 plus 2, which is 20. So this equals 28. Sorry about that. Okay, so that is the video for you of the review.